Hello guys, welcome back to Pooky Codes and to part 2 of Neural Networks Explained. So in this video we're going to look at how multiple inputs work in a neural network, and if not everything is clear with you, make sure to watch part 1 of Neural Networks Explained. So let's get started. Alright, let's get started. So, as a recap, we have seen that the simplest neural networks looks like the form y1 is equal to step w1 x1 plus b1. So I'm just going to say what each term refers to. So y1 is the output, x1 is the input, w1 is the weight, and b1 is the bias. Step is the step activation function, so the function that looks like this. So now let's look at situations when you have multiple inputs. So again, with my funky scenarios. So I'm going to start by calculating the quality of a meal. So I'm going to have a list of ingredients, and each ingredient will have a rating to it. So for example, when I eat asparagus, it's pretty disgusting. So I give a rating of -3. It ranges from -5 to 5, where 5 is godly and -5 is absolutely disgusting. And then for pizza, I mean, it's pretty good, but it's not really healthy. I don't really like it that much, so I put a 2. But for fried rice, it's absolutely delicious, so I give a rating of 5. So how do I calculate the quality of meal given these 3 ingredients? I'm going to use a simple metric. I'm just going to say, when you eat, you're going to sum every rating together, the ratings of the ingredients that you ate, and if the collective rating is bigger than 7, then it's a good meal. Otherwise, it's disgusting. So, for example, if I have 2 fried rice, it will be 2 times 5, the rating of a fried rice, which is equal to 10. And so this is really good food. And if I have 10 fried rice, hallelujah. But if I have 1 asparagus and 1 pizza, it'll give me 1 portion times -3, the rating of asparagus, and the rating of pizza, so 1 times 2. So -3 plus 2 gives -1, which is below 7, so the food is not good. If I have 3 pizzas, I would have 3 times 1, which would give me a rating of 3. And that's not good enough because I want it to be above 7. So let's write down the formula. So the formula looks like x1 is the number of asparagus, x2 is the number of pizza, and x3 is the number of fried rice. y1 is going to be 0 if the food is not good, and 1 if the food is good. So how do I calculate the rating? I just multiply the portions by its rating. So -3 times x1, then 2 times x2, and 5 times x3. So -3 times the number of asparagus, plus 2 times the number of pizza, plus 5 times the number of fried rice. And I also want to know that when it's bigger than 7, it's good. So the function overall is then y1 is equal to step of the rating -3x1 plus 2x2 plus 5x3, and then you wanted that only when it's above 7 that it's going to output a 1. So you have to say -7. So if we test that with the previous examples, we can see that, for example, 2 fried rice give me a rating of 10, and then if I substitute that part, this part, by 10, I'll get 10 minus 7, which gives me 3. And step of 3, because it's bigger than 0, gives me 1. If I, for example, take 1 asparagus and 1 pizza with -1, and I substitute in the rating, I'll get that here it's going to be -1, -7, which is going to be -8. That's way below 0. So it's going to give me, as an output, step of -8 is 0. So we have now looked at an example with multiple inputs, and we cannot deduce the generalized form of it. So the generalized form is of the form y1 is equal to step of w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 and so on, and then you add the bias plus b1. So this is the weight, this is also a weight, this is also a weight, and then this is an input, this is an input, and this is also an input. So we can now create a even more compact form, but it requires a much more advanced mathematical notation, but you guys will get it. So I'm going to use a symbol called sigma, which represents a sum. So what I'm going to say is that y1 is equal to step of sigma I equal to 1 from n of wi xi, and then I add b1. So what this means is that I take all elements from 1 to n, where n is the number of inputs I have, and I take their weights at that index times the input at that index. So for example, this would then give me, when I is equal to 1, it will be w1 x1, and then when I becomes 2, it will be w2 x2, and when I becomes 3, it will become w3 x3, and so on and so on. And then it goes up until n. So in this case, n is going to be w3 x3, so number 3. And so we have looked at how neural networks work when it is with multiple inputs. That's all. It's pretty easy. So in the next video, we are going to look at a specific problem called the XOR problem, which is now the real time for neural networks to shine. So see you next time. Alright, so thanks for watching. If you like this content, subscribe, like, and do all that good stuff. And in the next video, we're going to look at the XOR, which is even more cooler. So see you next time.